Thank you very much, Herve.
Okay, I shared my screen. Are you seeing my screen?
Yes.
Yes, I do.
Yes, I do too.
Okay, thank you. So welcome to this RUC-APS session. We are in the middle of the second week of the workshop, and I will present the work that we have done in some work that we have done in work package 11 in terms of enterprise system interoperability assessment with, let's say, an application in agriculture domain. So I'm Herve Panetto. I am a professor at the University of Lorraine in France, in the northeast of France, and I'm a researcher in the Research Center for Automatic Control, which is a big research lab of around 150 researchers in all domains of computer engineering and automatic control. In this work in RUC-APS, we have a team here at the university. So I'm leading the work package 11 of RUC-APS, and I'm a specialist in interoperability of systems and cyber physical systems. But I'm working with Dr. Mario Lezosh, who is more interested by knowledge management and ontology. Directly working with me on this subject, I have also Widad Gedria, who is associate researcher at the lab because she's senior researcher at LIST, the Luxembourg Institute of Science and Technology. She's working on interoperability assessment. And together with Widad Gedria, we had a PhD student that finished now since quite a few months, Gabriel Lille, who works on ontology-based interoperability requirements, and he is the one who developed the tool or the prototype of the tool that I will present to you today. And I'm working also with Concheta Semeraro, who is finishing her PhD. She will defend her PhD next month in June. And she's more specialist on data mining and digital twin. In RUC-APS, I'm working with these people and also with two colleagues that are not in my team, but we are working together, and they will also participate in some RUC-APS secondments. He is Dr. William Dirigeant. He's specialist in data management and building information modeling, mainly, but also many other things. And Professor Ind El Aouzi, who is specialist in simulation-based decision making. So let me start about the subject to go in the heart of the problem. So the problem of interoperability. So what is interoperability? Interoperability is making systems working better when they are working together, and for working together they have to exchange information, knowledge, product, and understand what they are doing and what the others are doing. So when you have a product, any kind of product, here in this slide is ice cream. I should have put maybe some vegetable for all caps. Sorry, I forgot to change that. I put the color green, but I forgot to change that. Okay, it's an ice cream. To build that product, many people, many companies, many systems need to work on part of that product, and they have to work to produce some part of it and to coordinate what they are doing. In fact, each of them are doing something, and at the end, all together, they work better to produce this final product. In order to produce together a product, they need also to exchange knowledge about that product. So there is knowledge that is exchanged between those systems, those enterprises, those companies, and this knowledge must be understood by each of them and produced by each of them to be used and to be shared by all people. This knowledge is most of the time represented by information. Information is some data coming from those systems, which a kind of interpretation. So sharing data and understanding the data means that we can understand what the data is related on, then we can have knowledge, then we can have products. The problem is that sometimes this exchange of information is not working, either because there is not too much IT to do that, either there is IT, but that information is not well understood by the system who is using it. So when and where we have this problem, we need to assess. We need to assess if the information is exchanged in a good way, and what can be done to improve this exchange of information that will be a base to exchange knowledge and then products. So assessment is there. Assessment is between systems, between enterprises, between people, between knowledge. There we have an assessment. So what I'm saying now, it's not specific to agriculture or to agribusiness. It's true for any kind of business, any kind of enterprise. So what we worked is, if we adapt what we have done to the agribusiness, is to develop a tool helping to assess interoperability between systems in agriculture. So I call that the Agri-Food 4.0 assessment tool. The objective is that we can assess interoperability everywhere. That interoperability is also important for humans, because sometimes information is exchanged manually by humans, so humans must understand. However, we have more and more IT, we have more and more sensors, we have cyber physical systems, we have actuators, we have also sometimes AI, artificial intelligence, so we have a lot of technology. We must exchange data, information, and knowledge. And this happens along the whole global value chain. So assessing the interoperability is important when we create a network. If we have to select new partners, then we have to understand if we can work with them, not only at the organizational point of view, but also at the technical point of view. Or sometimes we have companies that have been impacted by different curves. Currently, we have the COVID-19, and they need to transform themselves to be more reactive, to be different kind of transformation. In such case, we need also to assess interoperability. What can we assess? We can assess three kinds of properties of interoperability. First of all, the potentiality, which is the potential of an enterprise, of a system in general, to interoperate, to be interoperable in its environment. The potentiality means that we don't know yet with whom we will interoperate, with whom we will collaborate, with whom we will work. But we want to be ready to be able to interoperate with anyone that would like to cooperate with us. So this is the potentiality. When we know with whom we want to work with, then we need to assess the compatibility. We must understand if two enterprises are compatible at the business level, at the service level, at the knowledge level, at the data level, to work together. Most of the time they are not 100% compatible, but at least we have to evaluate how much we are compatible. If then we can put a kind of threshold, and if we are below that threshold, it's impossible to work well with that company. It's better to change and to find a new partner. If we are up this threshold, then probably we can work together, maybe not completely well, but sufficiently to do business. In fact, being well or not well, it's the performance. So we have also to evaluate the performance of the interoperation. Are we interoperable at 100%, at 90%, 70%, 20%? And this is important to understand where we have to improve, first of all, and what we have to improve. In order to analyze that interoperability, we base our work, and the tool is based on a meta model, conceptual model, which is a meta model about assessment. In fact, in this meta model, there is two parts. There is the core systemic part, which is the part representing a system in general. And it can be an enterprise or not. A system is defined by some requirements and has some quality characteristics that have some quality attributes. So for each system, we have those elements. And if we want to assess that system, we have the assessment part of that meta model. It means that the system is the object of assessment, and then we have an assessment process based most of the time with standards like the ISO 9001, ISO 33001, ISO. Well, there's only these two, but many kind of standards. In order to have that process of assessment, we should define some evaluation criteria, and we should understand what is the scope of the assessment, and we have to, when we have some problem of assessment based on the three properties that I showed before, we have to find some solutions. In fact, those solutions are generic. So we have a list of solutions, and we have to understand which is the solution that is interesting, that can be recommended in order to remove a specific problem that causes some mismatch with some requirements of that system, as you can see in this meta model. So using this meta model, we develop, Gabriel mainly, but I will say we develop an ontology, the ontology of the assessment of a system. So with that ontology, which is the base of assessing any system, okay, we extended it in order to assess the interoperability of one or more enterprise. So as you can see, we have some subclasses here in some concepts that are specific to what we want to assess. So this is the interoperability assessment meta model. So the problem is to remove interoperability barriers on top left here of this meta model. Okay, the solutions are based on best practices. So this is the main difficulties, is to understand what are the best practices, because some of those best practices are independent of the domain, but some best practices are specific to the domain. And in RUC-APS, one thing that we want to reach at the end of the project is to have a set of best practices in agrobusiness that are maybe not the same as best practices in automotive industry or best practices in medical industry. I don't know. The quality, the characteristic that we want to measure is the three characteristics of the interoperability that I told before. The object of the assessment is a system which is an enterprise. and we have to follow some interoperability requirements for that enterprise. And those quality attributes are known here as interoperability areas. Once we have that extended meta model, understanding what are the best practices means that we have to instantiate it for specific enterprises, so with specific requirements, specific attributes, specific barrier, a list of best practices. And we can use some inference engine that look at the ontology and that infers some recommendations. So what the tool is doing is exactly this. It takes the generic ontology of interoperability, this one, instantiate it, asking some question to some assessors. So that instantiation is based on some interviews of assessors. And based on those interviews and that instantiation, an inference engine is used to infer what is the knowledge hidden behind this ontology that express some recommendations based on the best practices. So, for example, if we instantiate those some of those concepts, here the enterprise, we can instantiate it with one specific enterprise. Here the enterprise name is Exos. Okay. The requirements is instantiated, so we have some requirements at the conceptual level, some requirements at the semantic level, at the technical level. So this is one example of one instantiation of the requirements. Here the requirements, PCR1 is process model shall be defined and documented. This is a generic and quite a general requirement. Those requirements can be more specialized. In terms of barrier, the two barriers that we have for this requirement is a problem of incompatibility in process semantics or a problem of incompatibility of exchange formats. Most of the time, the problem is exchange formats because this is the basis of the exchange. Then, when we are able to exchange some data, we have some semantic problem because that data is not referring to the same concept. So from that instance, okay, we can instantiate completely the ontology. So this is, for example, for the Exos, the instantiation of the ontology with many instances with relationship between the instances. Of course, this is done automatically by the tool, and you don't need to read and to see that. It's only to explain a little bit how it works. So this is the instantiation of that ontology for a particular case. You know. In fact, the prototype can be specialized for agriculture if we have an ontology of agriculture systems and if we have recommendations which are best practices in the agriculture domain. So the tool provides some user interface. It identifies some barriers based on some requirements. So the assessor has to rate the requirements to say if those requirements are completely achieved, partially achieved, or not achieved. And then the tool, using inference engine, we use in our case the Pellet open inference engine, but open Pellet, but we can use different. Well, this is a kind of technology. And then the tool recommends some solutions based on the identified barriers and based on some knowledge that is stored in terms of best practices. So the prototype has this architecture. So first we have to be prepared, because we have to define what we want to assess. So we have a lead assessor. The lead assessor prepare the assessment, gather some data, validate those data, and assign some specific assessment to specific assessors, because each assessor that participates to the assessment have its own competencies, own specialties. Then when the assessor assess some barrier, and some
I'm sorry to interrupt, but I see the screen in white in my case, just in case.
Just white for you?
Yes,
And
all white.
For me, it's okay. I continue to see the presentation.
Well, it
It's
may be
okay.
a problem of you.
For me, it's okay, yeah.
Yeah, for me
Okay,
it's
maybe
okay.
it's my
too.
problem. Sorry.
So it's
For me, it's
your,
okay also.
it's not a problem. I hope that you will see better after when I will do the demonstration of the tool. Then, when the assessors have assessed some part of each one its own part, the lead assessor has to use the tool in order to aggregate all the assessment using, and the tool is using some fuzzy logic API in order to aggregate the assessment, because you know that each assessor is assessing different parts, but with some correlation between these parts. And so sometimes it's not only calculation, it's not one by one, because 1 plus 1, because what say the assessor is that this is achieved, this is partially achieved, which is not achieved. So it's not only, it's fuzzy, okay? And the tool generates those ontologies, and at the end, it generates a report that we can give to the assessed company, where all recommendations are explained in order to help that company to, little by little, if it is sometimes, try to solve those problems using that recommendations. In order to infer some recommendation, the prototype is based on logical rules for the reasoning. So these are examples of rules. These rules depend on the domain. So it means that for the agribusiness, we need to define our own rules, which is not so easy, because we have to be knowledgeable on that domain, which is the agrobusiness. Only to show you, this is, for example, using the Protégé tool, the ontology before reasoning, so the ontology with those instances, and after the reasoning, the tool is creating that completing this ontology with some recommendations that are inferred. So you can see here in this example, we have eight recommendations that have been inferred by the inference engine based on what the assessors, how the assessors evaluated all processes. And we have at the end, a figure like this one, that in terms of assessment, first of all, give a level of assessment. So we use one maturity model named MMAEI, where we can define different level of assessment. Level 0 is unprepared. It means that it's not really good, but we have 4 levels, if I remember, of assessment. And this assessment can be done in 3, let's say, areas: the conceptual area, the technological area, and the organizational area. So it's the global result of the assessment, not explained. The explanation is in the full PDF report. And so, as you can see, some interoperability are fully achieved, other ones are not achieved, partially achieved, or largely achieved, depending on if it is at the business level, process level, service level, or data level. And as you can see here, we can edit if we want to change something, and we can generate the PDF. But you will see that in the tool when I will launch the tool just in a few minutes. So in the case study, we have 5 companies that are working together. We have all these companies are fictive, of course. They don't exist, at least they don't exist in the agribusiness. We have the factory group, which is an agri-food producer, not productor. Sorry, it's a mistake of my. I will correct that. Agri-food producer and supplier. Then is composed or is working with 3 enterprises. Exus, which is a farm that produces some vegetable. AgroInteract, which is let's say a transport company that transport the food from the farm to the warehouses of the factory group, and also from the warehouses of the factory group and the distributor. And the factory group is working with another company named Sustain that is there only to do some quality control. So it means that the quality control is not done by factory group itself, because, you know, when we want to assess the quality of something, we cannot be in the system and assess what we are doing, because we cannot find what is bad. It's better to have an external company doing that for you, which is completely independent. That company name is named Sustain. So as you can see, they are working together. They have to exchange some data about the product, some information about the processes, because for the quality control, we need information of the processes. For the transport is the product and the way that the product is then transported to the distributor. The distributor name is Riddle. So there are many things that have to be done together. And we need to assess in which way they are working well together. So in the demonstration, I will mainly focus on the assessment of Exus. I can show also the assessment of the other companies if you want, but all of them are not maybe completely done. They are partially done. So for assessing those companies, we have to prepare that. So we have to define the name of the company, the purpose of the assessment, the type of assessment, the framework that we use. There are some text, the layer, the interoperability layer, the interoperability concerns. So is it conceptual, technical, organizational, and the concern is business, process, service, or data. It can be all of them or not. And each of these preparation is for one assessor. Maybe some assessors are only assessing conceptual for process and business. Another one, it will assess the technical layer for data and services, and the last one only the organizational for business. So each one of the assessors are its own competencies and will assess part of the interoperability concerns. Then the assessment is done by questions. So there are some questions you will see, and as you can see here, and the question, for example, here for the layer conceptual and business, there is some question like this one. I hope you can read. How well business models are defined or documented, and then the assessor is giving some rates. So largely achieved, not achieved, partially achieved, or fully achieved, and can also add some comments to explain why he thinks that it's not well done. You can also upload some evidence, some documents that demonstrate that is right, that these models are not well documented, or this standard is not well used, and so on. So you can upload documents, write comments, give a rate, and all assessors are doing that. All this information at one moment, aggregated, will be in the interoperability assessment of that enterprise named Access. So what the tool is doing, as you can see, it's instantiating the Access company with some specific link to some requirements, to some solutions, to some conditions. So the instantiated model is quite big, but of course this is hidden inside the tool. You will not see that. You can see it only if you take the instantiated ontology that is generated in a file, for people who can understand it, and then you can have that instantiated ontology in a file. And the report that it's generated automatically is this kind of report, but I will show you one of those reports. So the name Platin is the name of the project that we did Gedria had in list, and the project that financed the PhD of Gabriel. So the tool name is Platin Assessment Tool, which is an interoperability assessment report on a specific company. So as you can see here, but we show you in the real PDF, we identify, the report identifies some barriers, some solution with the rating, the explanation of the rating, the comment of the assessors, the extra document that have been uploaded. So this can be applied in agribusiness and companies. If we have the barriers, which are generic, but the solutions that may be sometimes specific to the domain, in our case, agribusiness. So for example, here, there's the barrier, this one is a high priority. So the barrier is the barrier about semantic business and syntactic incompatibilities. There are some best practices that are there, and some related requirements for this barrier. You can see, you can read some papers that from Gabriel, at least one paper, more than one paper, but this paper is interesting for if you are interested of the subject, in the journal Enterprise Information Systems, in Taylor and Francis, that has been published this year, or the PhD of Gabriel. It's written in English, so you can read it. You can find it on the university repository, also on my personal webpage. And Gabriel defended his PhD in January 2019, so it's a little bit more than 1 year ago. I will tell you that the name of the enterprises used in this demonstration are pretty fictive. It's a fiction. Before I start the demonstration on the tool, do we have some questions?
No, I'm fine, thank you.
Anyone else? No? Okay. Let me go to the demonstration of the tool, and then I will come back here for the conclusion. Do you see here the login of the tool?
No, Herve, I don't see the login of the tool.
Yes, I see
something that is coming. So we have to wait because my connection is quite it's not fast, so maybe we have to wait. I hope you will see what I have in the screen.
Now we see the login screen.
Yeah, now it's okay.
It's okay. So the tool is a tool, there is a database, a MySQL database, and the tool is developed in Java. It's using some API, OWL API, and Jena API for the inference engine. And as inference engine, we use OpenLet, which is an open source version of OpenLet. So maybe you don't know anything about this, so it's not so important. Just to, if you know, it's only to tell you how it is built. So in that assessment tool, we have to log with some login and password, and depending of if you are assessor or lead assessor, you have different possibility. So I will log with the login password of my former student, Gabriel. Gabriel, are you there? Because I know that I invited him to attend the meeting.
Yes, I'm here. Can you hear me?
Gabriel Lille?
Yes, can you hear me?
Yes, I can hear you. Yes, you are here. So I'm okay. So if I'm saying something wrong, you can correct me, because you're better skilled than me on that tool and on what you have done, because it's your job.
Yeah, no, of course. You know. Until now, it's okay. Everything's okay.
Okay, thank you. Okay, so I log with Gabriel logging because he created some. I work with that logging initially to create some to use some existing assessment. If I have my one logging, but I have to create everything from scratch if I use mine, you know. So as you can see, Gabriel has a nice picture, and so we can either see visualize the any assessment that we prepare for assessors, or we can see the global list of assessment for all assessors and aggregate to have a result. So I will not go inside the assessment of one assessor because it's only defining, as you have seen before, which kind of interoperability concern and interoperability areas, and we want the assessor to do. So we define the different assessment and we assign them to the assessors. When the assessors log there, they can go there and they can see what has been assigned by a lead assessor, and they can do their job, which is assessing their competencies. Then the lead assessor, which is the boss. So here Gabriel is the boss, I'm not the boss.
Herve, just a question. I don't know if it's just me, the problem is the screen is freeze on the login page. I don't know if it's just for me.
I don't know. What about the others?
I can see it log as lead assessor.
Yeah, I can also see that log as a lead assessor.
Oh, okay. So yeah, just me. So I.
Yeah, it depends probably of the line if it is good or not. Mine is not good, but maybe yours is worst. I don't know.
Yeah. So sorry. Go on.
Right. So here we have, as you can see, 4 assessments of the four of the 4 enterprises, because we don't. In our case, we don't assess a factory group, which is the sponsor of that assessment, you know. And a factory group want to assess the 4 enterprises that is working with, in order to be sure that everything is working well between them. So we have Riddle, Access, AgroInteract, and Sustain, you know. So we can create new ones or not. In my case, I will open Access Maturity, the Access Enterprise. So as you can see, the lead assessor is Gabriel. We have Access. The sponsor is the factory group, and there is a kind of description. There are 2 assessors, because Gabriel, as lead assessor, assigned some assessment to the 2 assessors, and the concerns and the areas are all areas. It means all combination of business process service data together with conceptual, technical, and organizational. So the work of the lead assessor is to aggregate these two assessments from Gabriel and from Wided, in order to, if they are completed, because here you see on the right column there is one which is yes, they are finished. If they are not finished, he cannot do that. When it's finished, he can aggregate. Aggregating means that he can see the result of the aggregation using some fuzzy logic, let's say, combinations, of the business, process, service, data. So for each of them, we have the question that has been asked to one of the assessors, and we have here the aggregation of the rate. So it means that if it is not achieved, it means probably that both say no, or maybe only one say no and the other one didn't have to say anything because he's not skilled, and so we didn't ask. So you can see some are not achieved, some are largely achieved, some partially achieved, fully achieved. So this is the aggregation for the conceptual, technical, organizational at the business level, process level, service level, data level. So for example, as a data, if I take the first one on top left of that matrix, how well data models are defined and documented, not achieved. If I go at the technical level, for the first one, are data storage devices connectable and simple electronic exchange possible? Fully achieved. It means that those companies are able at least to exchange something, If I take always the first line and on the top right, the organizational, our responsibilities and authorities are defined and in place, fully achieved. So some things are well done. Then we can click on validate. The validate will verify that everything is complete, that there is not something wrong, something missing, that everything is done. Then when we are here, we can either come back to aggregation or generate the results. Generating the results means, what I said before, means instantiating the ontology, then launching the inference engine to infer some recommendation and to show those recommendations. I will not do that here because it's not too long. It takes 2, 3, 4 minutes, depending the size of the number of questions. Voilà. So I have already done that. And I think it's this one. I will show you the final result here, to save time, if you agree. Voilà. So normally you can see the assessment result. Are you all seeing assessment results? Which is the table with the crossing business process service data together with conceptual, technological, organizational, and with the small, let's say, icons saying that it's not achieved, fully achieved, partially achieved.
Yes. Yeah, okay.
So this is the result, a global view of the result. And then we can generate, or we can either edit to come back and to modify something if we don't agree, or we can export as a PDF. So we have some general information to be put there. We have to define what is the folder where the PDF has to be generated. Okay, and then it generates the PDF. Next, and I have to put a name, of course. Access report. .pdf. I don't remember if I had. I think now it's added because I made some correction on the tool. Done. Then here, not here. Sorry, this is the tool. Here you can see the maturity, the exist instantiated ontology that has been generated, and the inferred ontology that has been generated. You can see probably. Then I go to the repository here, and we have the access report. Let me see if I can open here. If not, I have it on my computer too. No, it's okay. So it's maybe small in your screen. So this is the report that has been generated today about the access company, and then we have a general information, we have the global result, and for each of the requirements, we have the evaluation and with some explanation about what is the barrier and what is compatible, what are the incompatibilities and the best practices that has to be put in place in order to. So, any question on the demonstrator?
Hi, Herve, this is Jorge. How are you planning to keep validating the tool that you develop? Is the plan for working in agricultural sector, or are you planning to move in any other sectors?
Well, I would like on the agriculture, but because some of the secondment didn't, we are postponed in 2021, it's not yet possible because we don't have everything. Also, for the ontology, Mario, together with Alejandro, Leandro, and Diego in La Plata, they are working on that ontology. Donc it's what Mario will present next Wednesday, yes.
The 27, yes.
27, and because we need that ontology in order to specialize that interoperability assessment ontology on assessing agribusiness enterprises, because the barriers are maybe not completely different, but the solution, the best practices are specific to each domain. So if we are able to use that ontology to specialize the interoperability assessment ontology, then it's easy in the tool to put that ontology in the tool, and then the tool will use this one to assess some barriers. So hopefully, I will be able to do that with that ontology and with those secondments that are missing now. But I cannot promise. I will try. And I know that Gabriel is interesting also if he has some time, because he's working now, to help me on that.
Sure.
Okay, thank you.
So what are the learning outcomes of this? Is that to do that, we have to analyze the data and the exchange of data in the food supply chain. We already started to analyze some application use in agribusiness because we have some secondments that help us to have this information, but not too much in the detail. We need to understand what are the information flows between agri-food stakeholders. And Mario, together with my colleague in La Plata, is working on the agri-ontology. I don't know how they call it, which is based, if I understood well, in the agri-food experiment ontology. We need also to have an interoperability map between the systems in agriculture domain to understand what can be exchanged between which systems in order to hopefully adapt the planting prototype to be an ontology-based interoperability assessment in agriculture. So, hopefully. Thank you. Any question?
Thank you, Herve.
Thank you, Herve.
Do you have some question? More question on that? Or maybe, Gabriel, you want to add something on what I said? Because you are the developer of the tool.
No, not exactly. I think that was quite clear what you presented, and also the possibility that you can expand that for other fields. And yeah, no, you can count on me if you need some help as well when I have more time. So yeah, no, it's quite good. Thank you.
Good. So if it was clear, it's because your PhD was clear.
I would like to know what was the most difficult part to develop this tool?
Gabriel, you developed the tool. I only corrected it, but you developed the tool.
Yeah, I would say that the part that was most difficult was the interface with the different APIs for inferring ontology and then reasoning, doing the reasoning, because that was quite hard at the beginning, and we had to change quite some time the different APIs. So, for example, Palette or I forgot the name of the other one. But I would say that just a summary, the most difficult part was the interface between the user interface, so the UI, with the API, the OE API actually.
Yes. And in fact, Gabriel developed with Palette, and I replaced it by OpenNet, because OpenNet is working better and is more easy to program. So I use OpenNet as an engine.
Okay, thank you.
So,
may I make a question?
Oh, yes.
Ask a question.
Yes.
So thank you, Herve, Mario. It's really nice to hear your voice again. We did a lot of work these past years, and nice to meet you, Gabriel. Nice work you did here. So my question is on the geek side, on the nerd side, knowing that you use ontologies to model the domain. Maybe some of these questions will come up again when I go to Mario's presentation. So knowing that you use ontologies to model the domain, and then I understand you use RDF and RDF tools to implement it. So you use Gina. I'm not sure. I didn't hear whether you use a triple store to store the data, or you use an SQL database. But anyway, my question is, what was the contribution of modeling the domain with ontologies instead of other approaches. And once you implemented, and this is special for Gabriel, what was your experience using RDF instead of, let's say, objects or classes to model and store your data? What was the experience? Will you do that again? Would you recommend me to use RDF as the implementation, RDF and Triple Store as the implementation of such systems? So really good questions. I hope they were clear.
Yeah, no, of course. What I can say. So yeah, just for the first question, we used SQL Server for the data, for storing the data. And the experience was quite, at the beginning it was quite new because I didn't knew ontologies as well. At the beginning of my PhD, I had just some knowledge on Java and oriented object and so on. But I thought that for what can you hear me? It's okay? But okay, so for what we were building at the time, the ontology was quite easy to manipulate. We use for modeling, that was the Protege tool. I don't know if you know it. Was quite, I would say, intuitive for modeling and defining the different relationships and these concepts, and then just for applying the logic was just 5 to 6 rules, semantic rules, and that to have I'd say a lot of power for reasoning, inferring, and then recommending the different scenarios based on the assessment. Otherwise, I tried as well to implement in parallel with some just if-then logic, for example, or different approaches. And for the quantity of questions or the requirements that you can add, and the atomic requirements as well, was huge, was kind of, and also to restrict and rigid, because if you want to change something, you need to go to the code and then change a lot of little constraints and restrictions. And the ontology was a bit quicker. Now I say that was quite good, was a nice approach. But I know that there is new technologies, but I didn't have the time to approach that yet. For example, you can try the knowledge graphs approach or Neo4j, for example, that I may say that can be used as well, but I don't know the power and the usability of these tools. But it's something that could be tried. But for my experience, just to summarize, is that was the better tool or better approach at the time for manipulating all the data and the inference and the reasoning.
Thanks a lot, Gabriel. Very clear.
You're welcome.
So I don't have any more questions. I have another one, but I will leave it for Mario's presentation, so he doesn't feel bad that I don't make any questions to him.
I will not be so clear as Gabriel did.
You will.
You will, don't worry.
There is a little